Noel.
Oh,
Okay. Where's the other one? Last scene 8:15. Okay. Wait first for one of your friends to come in. Then we begin our lecture for this morning. Okay.
so is there any midterm at 9:15? Yeah, I mean the quiz.
Quiz is on 10 o'clock.
Oh, okay.
Uh, so change the time a bit so you all can prepare and come in early into the lecture. Then you make yourself prepare for yourself. Then we begin the quiz. Like for this situation now, one of your friends, he come in and he got disconnected. Okay, now he's in. All right. Good morning. Uh, how to spell your name? Okay. So Kianwi at Kelvin Sharp.
Yeah, just call Kelvin.
Can call Kelvin, all right. So okay, for your info everybody, our quiz we will begin before our lecture. So the quiz edit a bit the time, make it at 9:10, okay, 9:10 a.m. until 9:20. So 10 minutes for your quiz. There's only 7 questions. Okay, 7 questions only, all multiple choice question. So what you need to do is the instructions there. You need to open the quiz question and then please use the bold function, okay, or highlight the answer that you chose. After that, you're gonna convert your file into a PDF and then you're gonna submit them via the submission, okay, via the assignment submission for your quiz, right? So just follow those steps when you want to answer for your quiz, right? Chapter 1 until chapter 4 only. And most of the questions are from your pre-practical question. Okay, last time Miss Paula, okay, she got shared with you all the question, okay, for pre-practical. So if you manage to answer the question on pre-practicals, for sure you are able to answer the quiz, right? So Kelvin, is your connection stable? Are your connection stable? Okay. Are you prepared or are you in a good or stable condition for your connection to answer the quiz that we're gonna have afterwards?
He left again.
Okay, he left again. Okay. Right, so a bit of introduction first, Noel and Kelvin. Okay, Kelvin's not in. Okay, last week, Miss Paula, the last lecture slide, where did she stop?
Oh, wait, I check.
Okay, the last chapter for week 7. Which chapter? The last chapter that she teach last week.
I think it's recursion, chapter 6.
Recursion. Recursion is chapter 6.
Yeah.
Uh, Chapter 6, recursion. So afterwards, we continue for sorted list. Okay,
Yeah.
sorted list, chapter 7. Okay, so prepare first, open. Okay. All right, Kelvin, how's your line? How's your internet connection? Okay. Right. So sharp at 9 o'clock, okay, 9:10 a.m. Okay, please check the Google Classroom. The link will be open for your quiz. So you try to check the Google Classroom. Okay, check the Google Classroom for this one, week 8. Okay, week 8. Okay, so already put in the schedule quiz for you all. So you need to wait another 4 minutes, 4 minutes more for the quiz. Okay, so in the meantime, okay, everyone. So our lecture for this week, sir will be taking over your class for Miss Paula. But okay, but just for your announcement, next week, do you all knew Miss Shikin, Miss Nora Shikin? Okay, if you knew her, okay, you all knew her. Okay, she will be taking over the class for this BSES 2063 data structure algorithm. Okay, because there's a slight change in the schedule, so maybe there will be another changes in your lectures, in your lecture, your tutor for this course. So don't worry. The course, the subjects, all of them will be proceeding fine, but just the lecturers and the tutors will be changed. Okay, link list. Okay, so if you all have any question, okay, if you all have any question about abstract data types, okay, for your assignment, mainly for your assignment, you don't have midterms, but you have quiz and your assignment, okay, and most of your assignments will be contributed a lot in your coursework mark, okay, your marks. So please, for your assignment, okay, you can do it, okay, do it in a way that you are satisfied with your results, okay, because your projects, your assignment, okay, it contributed a lot, so you must do the best of it, okay, so that you can get a very we can say that you are satisfied with the marks and your total score, okay, for this course. But my advice is, okay, don't make it too complex and don't make it too simple. As long as you got a code that is running, that is functioning, okay, change the code a bit. Make sure you don't leave any traces of reference, or maybe you got the code from Stack Overflow. Okay, usually us programmers, we use a lot of codes from Stack Overflow. Okay, that's a website. So you have to change the code and you have to get the output from the assignment. Okay, the designated output. Okay, once you can get those output and your codes are all neat and tidy and there's no bugs and there is no deadline. Okay, meaning to say that all the lines can be executed successfully and you got your output, for sure you can score and pass this course. Okay, that is my advice, sir. Okay, so sirs is from a software engineer background, so if you have any question, okay, you may ask, okay, regarding the assignment. Okay, but make sure you touch up first. Okay, your quiz gonna start in 10 seconds. Okay, please check the Google Classroom. So I think the link will be ready already. Okay, it will be up. Okay, so you can try to refresh schedule. Okay, maybe we wait a few more seconds for it to go out. Okay, maybe a few more seconds. Okay, are you all able to see the quiz? Should be out by now.
No.
Under week 8. Haven't I? Okay, please check the Google Classroom. Under week 8. Try to refresh it.
Oh, got ready.
Okay, all right. So it's out already. Okay. Right. You may do your quiz, everyone. Good luck. And please, okay. So Kelvin, you can check your Google Classroom. Okay, can we share a link? Copy link. Okay, all right. So yes, Kelvin, please check this link. Okay. Okay, link to quiz. This is the link to your quiz.
What's the password?
Okay, Noel already submitted. Thank you. Right, so we wait for Kelvin. Okay, Kelvin, just give the word that you have submitted, but the timer is till 9:30 a.m. Okay, we increase the time for you all to submit. Okay, so that you all have enough time to submit the. You want to convert the doc PDF and then you submit, right? So another 6 more minutes. We wait for another 6 more minutes for Kelvin to finish answering the quiz. Okay, Kelvin, already submitted. Hold on, so check first. Okay, all right. So, sir already received the submission for your quiz. Okay, just a slight glimpse look at the quiz, and for sure, most of you got 6 per 7, and may 6 or 7, 5 above. Okay, just a quick glimpse. Just now, check 5, 6, 7, more than half. Okay, so yes, the results will be out later. Okay, just check the Google Classroom, and so we'll give you the score. Right. So done, everyone, for your quiz. So how was the quiz? Is it hard or is it too simple, too easy? Okay,
Easy.
easy for Noel. Kelvin, how about Kelvin? Simple. Okay, if it's easy, let us check. All of you, if you all manage to get a perfect score, 7 out of 7, then congrats. But if you got one question wrong, okay, you can use Google Form, but this is another method. Okay, so want to use the plagiarism checker report. Okay, so want to use the report for documentation. All right. Yes. You can also use Google Form, or we can also use Quizlet or other method, but still need the report. Okay. All right, so thank you everyone. Let us proceed with our lecture. Okay, for this week, sir will be teaching you data structure and algorithms. Okay, we will proceed our lecture on the next chapter on the list, which is chapter 7. Okay, which is chapter 7. Okay, hold on. Okay, so we record first. Okay, so let us proceed with our lecture. Okay, can you all see my screen? Please raise your hand if you can see the screen that I share with you all. All right. So can you see a drawing of a pencil, a pen here? Can you all
I
see the
can.
drawing? Can? All right. So I will be using a lot of pencils and drawers to highlight the important things in your lecture. All right. So sorted list will be on the next lecture that you all gonna go through, which is chapter 7 for sorted list. Okay, so a bit of an introduction first. Okay, a bit of an introduction first. What are these sorted list is? Okay, for the ADT, okay, for the ADT, abstract data type list, okay, this is list. Entries are ordered simply by their positions. Okay, so however, some application require sorted data. Why do we need to sort our data? Okay, ADT maintains data in sorted order so that we can achieve conveniency. Okay, we as a programmer, okay, as a software developer or a software engineer, after you go to companies and work in programming industries, okay, conveniency is what the boss wants in your codes. Okay, it doesn't matter if you are developing a Java based, a C++, a C, or any other language based programming. Conveniency is a must for your code, right? So your boss can see the codes is neatly and conveniently to be checked and distributed to their clients. Okay, they don't want just how the client want their output for their developed product, but this product can be passed on. It can be passed on to their third parties. Maybe they want to do their in-house programmer. Okay, we are the third parties. We do an application for them, and we give those applications codes and all of those projects sample files and also the programming codes to them, okay, they can conveniently see the data, right? So it will lessen their burden when they want to further develop the application that we use. All right. So learning outcome here is you should be able to use a sorted list in a program. Okay, you are describing differences between abstract data type and also sorted list. Implement ADT sorted list by using an array, and you need to sort list by using chain of linked nodes. Okay, chain of linked nodes, those nodes, they are chained together. Okay, so when you do a programming, this code needs to be chained in a nodes. Okay, so that the variable, they can refer to each object one by one, right? That's why we need to link the nodes of the codes, right? Okay, so these are some of the ADT that is sorted. Okay, we need to know what does it mean by the data first. Okay, data is a collection of objects in sorted order and same data type, right? The number of objects in the collection. Okay, we have a collection of objects, and a data is a sorted order of the same data type. Okay, same data type. If it's all of them are Boolean, true or false. Okay, all of them are integers. Okay, we describe them by those things, right? So we have operations here. Operations. Okay, remove an entry, add a new entry, remove an entry, check if the value is contained on the list, clear the list, check the number of entries, and check if the list is empty. So take note, a sorted list will not let you add or replace an entry by position. Okay, they have to add or replace by the statement. Okay, if you entry by position, then that we have other methods to do that lah. But for this operation and data for ADT sorted list, it must be in a sorted manner. Okay. Now we look at how you want to compare the entries. Compare the entries. Compare the entries in order to determine the correct location to insert a new entry. Okay. So the object in a sorted list must be comparable. Okay, what does it mean by comparable? You must use this method, compare to. Okay, later we look into a few codes. So to enforce this requirement, we write extend. Okay, extend in a programmer's life or in a programming way of doing a program, you extend the search. Okay, extend. This variable t is actually extending the search to comparable. Okay, or we are just simply extending the code to this comparable and t. Okay, they are just expanding the list. Maybe this list doesn't have the variable that it want, the object that it want, so it extends to this folder or this file or this code to search all the necessary code that they want to include in their maybe in their main folder, main files or execution files and all that. Okay. Okay. So sorted list information, we have these a few sample codes under chapter 7 ADT. Okay, I've already shared with you all in the Google Classroom. Okay, you may search them and find them. Okay, we have sorted list interface.java. Okay, sorted list interface.java. Note that the generic type declaration of the interface header we see extend. Okay, we have an extend in those file. Okay, sorted list interface Java. Okay, let me check the sample codes. Chapter 7. Okay, so file name again. Sorted list interface. Okay, so I'm gonna open with Notepad++. Okay, you see, this is the code that we want. Okay, this is the code that we want. This is the view. Okay. Okay. So as you can see, sorted list interface T extend to comparable T. Okay. So it extend this list because it wants to find a new object. Okay. So find a new object which is not inside the reach, but it is inside this file. That's why it extends. Okay. Sorted array list Java. Note that the generic type declaration in the class header, we have T extend comparable T. So note that the new statement to construct the array in the constructor, okay, this is the new statement to construct the constructor, sorted array list. This is under sorted array list. Okay, I'm gonna open up this one. Okay, this is it. Okay, this is the extend, and then it's gonna create a new file. List equal to T is, okay. So I'm gonna list out, okay. So I'm gonna, okay, it's beside here. The extend to this file, okay. Extend new comparable initial capacity, okay. So it's gonna take the new statement to construct an array in the constructor. Okay, so this is the constructor. So an array is initial capacity because the generic type enforces the requirement of the entries that are comparable. Okay, so when we get the object inside the extend file, we compare it in our array initial capacity. Okay, they are doing something. Okay, they are doing, maybe they want to search. Okay, that's why we need to compare them. Okay. Okay, so this array, you can see, okay, it's comparing the initial capacity, okay, because we already extend the value. So yes, that is what the code is talking about, right? It can be anything. They want to compare maybe values, or they want to compare inputs from the user that you get, anything, right? Okay, so we have a few codes here under sorted array list driver. Okay, sorted array list driver. Okay, for sure they got this extend. Okay, this extend declaration. Okay, and then they compare it to the initial value. Okay, that is so much for that code. Right. So let us look at sorted list implementation. Right, we have implementation. Okay. Right. So we have implementation here. Sorted list implementation. Okay, list implementation sample code you can get from sorted linked list. Okay, under the add method. If this list is ascending order, okay, if it's in an ascending order, okay, insert new entry just before the first entry, not smaller than new entry. Okay, so this is under sorted linked list Java. Okay, let me see the code. Sorted linked list, so it's in another folder. Okay, all right. So sorted linked list, which one we don't find? Add method. Okay, so let me search that for you all. Add method. Just the add method. Okay. Okay, so is it here? Yes, add a new entry. Okay, do we have any more add? Okay, do we have any more? Add in the middle. Okay, so it's gonna add in the beginning and in the middle. Okay, so this is what the code is talking about, right? If it's empty, they put in a new code at the beginning, and else they put in the middle or at the end of the before not. Okay, that is a new entry. Okay, the check add a new entry. Okay, right. So this code is talking about numbers of entry and the first node first node. All right. So it's gonna ask you to include a few nodes numbers, and then they're gonna add those in those linked lists, in those sorted links. Okay. Okay, when they add them inside, okay, this is the condition that they check. Okay, so yes, this is what the code is talking about. Okay, we have sorted link interface. Okay, so this is the method. From the code's view, we cannot actually see, but in this infographic, okay, we can see the method add. This is how they add it. Okay, all right. Imagine that you are actually inserting a new node, or we call it the first node. Okay, the first node, right? Ali. Okay, Ali is less than Bob. Okay, so Ali is gonna go through here. So you can see that Bob is higher than Ellie. Maybe he's the boss. Okay. So Katie is less than Jill. So Katie is gonna go here, this link. So Bob's gonna go here. Okay. Jill stays here. Luke is less than Mike. Okay. Sue is equal to Sue. So Sue. But Tom is greater than Sue. Okay, so Tom's gonna go here. Okay. So Tom's gonna go here. So what do we see from this method add? Okay, we add the node. Okay, we actually add them. Okay, the add gonna goes here. The add gonna goes here. Okay, add Ellie, but Ellie is less than Bob. So Bob stays here. Okay, Katie, compare it to Jill. Jill is bigger. So Jill stays here. Mike and Luke, who is bigger? Mike stays here. Sue is equal to Sue, so Sue stays. Tom is greater than Sue, so Tom's gonna stay here. If we have the list lah, if the list goes on and continues on, okay. But this is the condition that you need to check, maybe in the statement, okay. So you need to check whether or not which name or which person's gonna stays inside the list, okay. All right. Okay. So here's another method add explanation. Okay, this is recursive. Okay, recursively adding Luke to a sorted chain of name. Okay, so this infographic, okay, I can tell you all. On the first node here, we have Bob, Jill, Mike, and Sue. Okay, what happened here? Luke is greater than Bob. Okay, Luke is greater than Bob. So add Luke to the rest of the chain. Okay, so Luke's greater than Bob. Okay, so Luke's gonna go here. But the rule for Luke and Jill, we don't know. Okay, let's say Luke is greater than Jill. Okay, look at the second list. Luke is greater than Jill. So add Luke to the rest of the chain. Okay, so should be Luke is greater than Jill. So Jill, okay, Jill is at the back again. So Luke's gonna go forward to Mike. So we don't even know which is greater, Mike or Luke. So we look at the list again. Luke is less than Mike. So Mike is greater. So Mike's gonna be put inside. So Luke's here. So add Luke here. Okay, we add Luke here, but Luke is not inside the list. We look at the rule first. Where's Luke's gonna be in? Okay. So at the beginning of the rest of the chain, okay, at the rest of the chain, Luke remains on the chain. Okay, Luke remain on the chain, but we never know where Luke's gonna be put inside. Okay, depends on the code, depends on the statement. Okay, depends on the requirement that you put in. But recursively, we can say that we add Luke, we add Luke to the list, chain of name. Okay, we'll just add Luke, but Luke will never find a place until it is stated. Okay, but Luke is actually added to the sorted list. But where is it put? Luke is put inside the chain. The chain is that is connecting the name. Okay, the Luke is actually put inside the chain of names. Okay, so we never know where's the Luke's gonna put. Okay. Yes. So we have another method add here. Okay, this is another way of going it. The list before any addition. Okay, we have a first node here. So Bob is here. Jill, Mike, Sue. Okay, Bob, Jill, Mike, Sue. So add Ellie. Ellie, and at the first node begin the execution. So this is the first node. This is the current node. Okay, first node and current node. So Bob's gonna go here. So we are actually recursively adding a node to the beginning of the chain. Okay, we are actually including a node. Okay, we are actually adding Ellie, but Ellie we don't know where she's gonna put, but she is inside the chain. Okay, she is inside the chain, but we never know where Ellie is gonna be put. Maybe Ellie is gonna be put in a condition that she met. Okay, it depends on the code, but Ellie is inside the chain. Okay, Ellie is inside the chain. All right. So yes, we have another continuation here. After the new node is created, the base case, okay, Ellie is put inside here. Okay, this is a new node for Ellie. So Ellie is gonna go to the first node. After the public add, assign and return the reference of the first node. Okay. So yes, the first node, okay, the first node knows that Ellie is gonna be put inside. So the current node's gonna be distinguished. Okay, it's gonna be it's gonna be removed from the list, the chain. So Alice gonna go into the new chain. So Alice gonna go before Bob because that is the first node. Bob before this is the first node, but when Ellie comes in, it's gonna replace Bob. Okay, so Bob's gonna move forward in the chain. So Ellie's gonna move slightly behind Bob. Okay, under the chain. Okay, just refer to the code current node. We already remove it from the list, but first node's gonna take over Ellie. Okay, first node's gonna take over Ellie. Okay, first node's gonna take over Ellie, and Ellie's gonna go into the list. Okay, yes. So similarly, the idea here is we need to understand that where the first, okay, we look at the statement here. We look at the statement here. We look at the rule and condition. We don't know actually where you want to start the list until it is actually executed or described or put inside the code. Okay. When we have this list, Bob, Jill, Mike, Sue, a current node goes in. So Luke's gonna goes in. Luke gonna goes into the current node first, and then uh, recursive call. Okay, we have another condition here. Luke is still inside the current node, but he is skip. We call the method get next node. Okay, so Luke's not gonna go to the first node. It's gonna go to the next node. So it's gonna go over to Jill. Okay. Okay, we don't know how many loops there are. We don't know how many of the statements gonna be executed. But looking at the next condition here, by the looks of it, it's gonna go next. Okay, it's gonna go next, get next node. So it's gonna go to the get next node. It's gonna pass over Jill. It's already passed over Bob. So it's gonna go to Mike. So okay, it's gonna go to Mike. So until this condition is break, it will not stop. It look will not stop at which node. Okay, at which node until it is specified inside the code. So what we know here, current node look is actually in the chain before Mike. So usually if it stops here, it's gonna go over in front of Mike. You see? Okay, so it stops here. A new node is created at the base case. Okay, a new node is created at the base case. So the first node is here. Bob's is already skipped. Jill skipped. So the current node, okay, the private method returns the reference that is current node. Okay, so this method is gonna be returned. So Luke's gonna go inside Mike before Mike. Okay, but the chain need to allow Luke to go inside. Okay, how do we execute this command? You see, return reference is assigned to node after. Okay, so return reference, you can see, first node is the first node. So we execute node after. So the first node is gonna go to the current node. Okay, first node is gonna go after the current node. So current node is gonna be changed. Okay, so the current node is gonna be changed. Current node is gonna be changed here. We can see the first node is here, and current node is here, and node after is gonna take over the current node. So current node is actually Jill. So Jill is the current node, correct? Before Mike. So we cut loose the arrow. For Jill's arrows, Jill's chains, it's gonna be linked at Luke, and Luke gonna link again back to Mike. So actually we are including or inserting Luke between Jill and Mike. Okay, that is how the list look. Okay, okay, we can do this in programming language. Okay, we can do this in our programming. Okay, so Luke is inside here. Okay, current node, it distinguishes between the node after, so it put Luke's inside between Jill and Mike. Okay, yes, this is how the add. Okay, this is what the add method. This is how the add method they are insert and how they include inside the method. Okay, so recursively adding a node between existing nodes in a chain. Okay, right. So efficiently, okay, efficiency of the link implementation. Okay, this is how efficient it is. Okay, how efficient that you want to give the link implementation. Okay, so ADT sorted list, ADT sorted list operation, we have a new entry, add, we have remove, we have contain, we have clear, we get numbers of entries, and is empty. Okay, so look at the numbers. Okay, look at the numbers. For array, we return 0 with open and close bracket and numbers of new entry. Okay, new entry, we don't give 1, we don't give 0, but we give it an n variable because we don't know how many entries. Okay, we don't know how many entries gonna be include. Okay, it can be 1000 entries, it can be 500, it can be 10 entries, 20 entries, we never know, right? So if you want to remove an entry, this one we don't put it 0 or 1. Okay, we don't put it true or false, we just put it n numbers of an entry. Okay, because how do we know how to remove the entry if we don't know how we include a new entry? Okay, let's say we have 10 entries, so remove 10 entries. If we add in a new 0 and 0 numbers of new entry, so we just remove 0 numbers of an entry. Okay, contains also, we use n variables, n numbers, because we don't know how many can contain inside the list. So that's why we need to refer back to the new entry. Okay, the new entry is gonna be referenced by the remove and contains. So that's why when you use it on an array or even in linked list, we never use a fixed number, or we never use the condition to a condition that we specify that is fixed. Okay, so that's why we use n. Okay, n numbers. Okay, let the number of entry determine the number of n, right? But as you can see below here, for for clear get number of entries and is empty, we didn't use numbers of n, but we use 1. Okay, we make it true. Okay, make it true. So whenever you want to clear something inside the list, you just make it 1. 1 is true. Okay, so we execute the number. We execute the method, clear method. Okay, get number of entries, also 1. Okay, because we want the entry to, we want to get the entry from add, remove, from add. Okay, and is empty, we want to check the condition whether it's empty or not. So that's why we put 1. So it will always check the number. Okay, if it's true or false, so we put it 1 so that it can check whether it's empty or not empty. Okay, same goes for link. Okay, array and link, right? Array and link. Later we see which one is better, array or link. Okay, this one. Okay, so I'm still in. Okay, all right. So the worst case efficiency of the operation on the ADT is on the sorted list of 2 implementation. Okay, all right. So yes, we managed to finish our chapter 7. We have an exercise here. Compare and contrast how each of the following method would be implemented in unsorted lists and sorted lists using link implementation. Okay, provide detailed explanation. Your answer may include appropriate diagram for illustration. Okay, sorted and unsorted lists. Okay, we have 2 types, sorted and unsorted. Just now we see a sorted list. Okay, sorted list, as you can see, sorted list is a list that, yes, you sort them. This is a proper sorted list. Okay, and you may use diagram. You can use to draw and explain each and one. Okay, we have our explanation here. Okay, so a sorted list is like a list where it is properly listed. Okay, like for example, when you go to McD or KFC, okay, what did you do? Okay, have you all go through the McD drive-through in Jalan Bundusan, there, Beverly Hills? Okay, when you
Oh
go
yeah.
to go through drive-through, right? You, okay, there's a long queue there. Even the queue is reaching the highway. Okay, so already, that's why when so passed by there, okay, when you see there's a long queue there, okay, then you change your mind. Okay, no, I'm not eating McD today. The line is very, very long, so if you to queue, right? So think of it as a sorted list. Okay, you queue for your double cheeseburger. But what happened? Okay, what happened if you are actually using an unsorted list? Okay? Unsorted list like this example. Okay, okay, just think of this as an example, right? You go to the McD again, and you see, but actually now you are driving a motorcycle. Okay, you are not driving a car. Okay, so this motorcycle that you bring to the McD drive-through. Okay, you go each and every one of the car until you make yourself at the order booth. Okay, so you cut a few cars just to go through the order booth and make your order there. You are using motorcycles. If and only if there's no staff there, they want to stop you by cutting over the line, or there's no one telling you that this is wrong. Okay, so think of it as an unsorted list. All right, unsorted list. So you have two methods. Okay, even if you drove a car and you are like a VIP there, okay, you can actually cut all those cars and go to the order booth using your luxury car or something. Okay, so when we see this question, you compare and contrast unsorted and sorted list using link implementation. So you need to draw the link. You draw the link. You draw the link one by one. You like this. You draw this. Okay. Okay. Maybe you can try explaining sorted list first. Then you try to explain unsorted list. Okay. But there are a few technical terms you need to state when you want to describe them. And you can draw an illustration. Okay, can draw an illustration by using this code. Okay, it's a simple 6 marks question. Okay, void, you add a new entry, which is t is a new entry, add the given entry to the list. Okay, so maybe you can use a few entry lists here, so you can choose which one you want to put in t. Okay, so if you explain using sorted list first, you explain t is gonna start from here at the top. But when you want to change unsorted list, maybe you can put t here. What happened here? And then t is gonna move here. What happened here? And t is gonna move here. What happened here? So this link, if t stops here, t is gonna be put inside the new link. Okay. So compare and contrast using this code. Okay. Right. Okay. So what did you learn just now? Learning outcomes. You should be able to use a sorted list in a program. Okay, you describe the difference between the ADT list and sorted list. Okay. Implement sorted list using an array and sorted list using a chain of linked nodes. Okay, chain of linked nodes. That is one of the question that most of us can tackle during the exam. Okay, right. Okay, so now it's 10 o'clock. Okay, so hold on. I'm gonna open up a new lecture slide for you all. Miss Paula already shared with you all the lectures, right?
Yeah.
Yeah.
Okay, hold on. Okay. Okay, so you all understand sorted list?
Yeah.
It's quite easy, right? You just have to know the method. Okay, just for this sorted list, this example they use the add method. So actually there's a lot of method that you can use actually, but add method is one of the easiest command that you can use. Okay, the easiest method that you can most of us see in a list example. Okay, all right. So let me close this one first. Okay, right. So we proceed. Okay, algorithm for sorting. Okay, just now we look at linked lists. So now we'll use algorithms for sorting. Okay, so data structure and algorithm, we have a few algorithms. Okay, just now you learn data structure. Okay, now you learn the algorithm part. Okay, the algorithm, what are the algorithms for sorting? Okay, so at the end of this chapter, you should be able to sort an array using sorting method. Okay, we have bubble sort, we have selection, we have insertion, we have merge, and we have quick sort. Okay, assess the time efficiency of various sorting method. Okay, express in big O notation. Okay, all right, bubble sort. We look at bubble sort. Okay, we look at bubble sort first. What is bubble sort, everybody? Okay, bubble sort. Okay, so bubble sort is the simplest, okay, the simplest and slowest algorithm. Even though it's one of the simplest, but it is one of the most slowest algorithm. Okay, the most slowest algorithm that you can find in a sorting algorithm, right? So what does bubble sort do? It compares two adjacent elements sequentially and swap them if they are out of order. Okay, so it uses iteration. Okay, it uses iteration plus 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 or minus minus to move the target element to the end of the array. Okay, so the largest element is being put at the end of the array. So how about the smallest element? The smallest element, we move it in front of the array. Okay, for example, if you have 1 until 10, so definitely 10 would be at the back of the array. So the first number would be the first array. Maybe we can use a different example. Okay. Okay, let's say you have motorcycles and a car. Okay. So motorcycles and car during traffic jam, you can see during a traffic light. Can you all imagine a traffic light? All of the motorcycles move to the front, in front of the traffic light. Okay, and the cars, they need to queue at the back. All right. So bubble sort is like that. We sort the smallest value first, the small motorcycles at the front of the traffic light, and all of the other cars they are queuing at the back of the traffic light. Okay, because they are big. Okay, they cannot pass through the corners inside the cars. Motorcycles can do that. So a bubble sort, okay, a bubble sort because a larger value gradually bubble to the end of the array. What does it mean by bubbling? Okay, you all know how bubbles is created. Okay, you blow the soap and the bubbles get bigger. So the bigger the bubble, the heavier it gets, and it will drop from your hand and then it will pop up. Okay, so the bubble sort is like that. Okay, it's gradually it gets bigger and it will be moved to the end of the array. But this is giving the algorithm a disadvantage where the algorithm tends to be slow. Okay, so it tends to be slow. When it slows down, it cannot make the right execution time for the code. So it makes several passes through the array. So each pass, neighboring pairs or elements, they are compared. Okay, so if the pair is increasing order, we leave the value as they are. Okay, this one is easy. If the pair is decreasing order, we swap the value. Okay, you invert the value. If it's 1 until 10, then we just leave the value as they are. But if it's 10 to 1, we use bubble sort. We have to invert the value. Okay, we have to invert the list. Okay, make it 110, not 10-1. All right. So that is the idea for a bubble sort. Okay. Yes, this is bubble sort example. The first pass. Originally, we can see here the bigger the value, it will be compared to its neighboring number. And after it compares, it will move forward or it will move to the back of the list. Okay, as you can see here, we have example for 23, 78. See, the second number is already the largest. Third number, 45, 8, 32, 56. So we see that the largest number here is 78. So 78 is going to compare itself with 45. So who is bigger? 78. So 45 is going to move to the front. 78 going to move to the back. Okay. This is the front. This is the front. This is the back. Okay. This is the back. So we compare again 78, 8 for sure. 8's smaller than 78. It's going to move forward. 78 is going to compare with 32. 32 is going to move forward and 78 is going to move at the back. 78 compared by 56. 56 is going to forward and 78 going to move to the back up until it's going to be at the end of the okay, this is array. Okay, at the back end of the array. End of pass 1. Okay, we have a lot of pass. Okay, I can see here when you use bubble sort, okay, you need to sort the array until the lowest value should be at the front or at the first array, and the largest array should be moved at the back. Okay, it's simple as that. This is the idea for bubble sort. Okay, yes, now we look at the second pass. Just now 45 is the one's gonna move forward after 78. So when 78 move at the back, 45 is gonna replace the location. Okay, 45 then is compared with the number of its neighbors. So 45, 8, 8 move forward back. 48, 32, 30 moves forward, 45. 45 compare with 56. So what happened here? There's no sorts coming in because 45 is smaller than 56. So 56 remain at its place and it locks the array. So we have a few more passes that are gonna be executed. This is unsorted array. This is not yet sorted because we haven't seen 8 moving at the front yet. So these are sorted subarray. So we move to the third pass. Again, we repeat the same thing. Same thing again happen. 28, 23 compare by 38. So 8 is going to move forward and 23. So 23 compare by 32. Yes. 32 is bigger. So 32 compare by 45. 45 gonna stays. 32 is gonna stays. Okay. So 23 and 8 gonna stays here. So this unsorted list. Okay, 45 not yet. This phase is actually not finished until you get all oranges. Okay, but we need to do one more pass. But I think you need to describe the pass. Okay, even though you know logically or observing from the past, you see this one no need to do the calculation. I no need to do the swapping again I think this is the answer. No, you need to state the last pass. Okay, you need to state the last pass, end of pass 4. You need to state this. But if you state your answer that it ends on pass 3, okay, you think this is the answer, then you write down there end of pass 3. So you just put there all of these are in a sorted array. It's wrong, Okay, maybe sir thinking of putting each of the algorithm inside so you all know how to compare. Okay, so this one, then you conclude here. This is a sorted sub-array. It's not unsorted. No, you have to do another pass to make sure everything is in order. Okay, so just write down write down one more pass, which is the fourth pass, and then you compare 8, 23 to 2. If you determine already that is the value, then you lock the answer, all sorted, since there were no swaps performed in this pass. Okay, so this is the answer, right? This is the answer for bubble sort. This is the answer for bubble sort, right? Yes. But we have our pros and cons under bubble sort. Okay, the bubble sort algorithm can detect a sorted array when there is a pass. Okay, when there is a pass with no swaps. What does it mean by that? Okay, sorted array when there is a pass with no swap. So this bubble sort algorithm, they can only detect that, okay, we need to do swaps. Okay, we need to do swap. We need to pass. Okay, we need to pass. But if there are no swaps, then what's the use of bubble sort? Okay. So the best case for bubble sort that it sorts needs only the first pass to the sort array. No pass is needed. Okay. So bubble need to sort only the first pass to sort the array. That is the best case. Okay. Since the number of comparison is n minus 1 in the first pass, the best case time is 0n. Okay. What does it mean by that? If bubble sort can solve the list, the array, only one time, then it's good. Then it's the best case for them. Okay. But the worst case here is inverted array, maximum pass n minus 1 is required. So if you did the one just now, we got until 4 passes. So each pass requires maximum comparison. Then the first pass takes n minus comparison, the second takes n minus 2 comparison, and so on. Okay. The worst case is 0 number in the power of 2. It doubles the value from 0, 1. Okay. Like let's say we use bubble sort. We only managed to do one swap. Then it's okay. It's the best case. Okay. That is the best case. But if you did the swap to the power of 2, let's say you do 4 swap, 4, 16 case time. Habis. You're actually doing a worst case for the bubble sort. Okay, you are doing a lot of swaps, so maybe this will delay the time of the execution of the code. So this is one of the disadvantage of it for bubble sort. Okay, bubble sort can be seen under chapter 8 sorting. So this I will share with you all. Okay, I will share with you all this code. Okay. Okay, give 1 or 2 minutes to share with you all in the class. Okay, you can have a look at it. Okay. Okay. So the code is in. Okay. So we use the code. right? So you can see this is the bubble sort that's shared with you all in the Google Classroom. Okay, you can analyze this code, but the idea here is I want you all to look is this loop, because this loop it has a condition there. Okay, pass equal to 1, pass less than the numbers, then not equal to sort. Okay, it will not sort, but if it less than, then it sorts. Okay, if it's greater than, then it sort, because we have exclamation mark here, so it will not sort. So we just pass forward, look again for any condition. Integer index is equal to 0, the index is less than the number of minus pass, so we just index them. Okay, swap adjacent element if first is greater than the second. Okay, so here if it's greater than, then we swap it. Okay, swap adjacent element. Sort pass sort equal to false, array not sorted because a swap was performed. Yes. So when we perform a swap and we compare it again, if the value is greater than, then we need to do the swap again. If not, they will stop the swap and the array will be sorted, and they will not execute any more sorting because we already swapped them. Okay. So this one, this is for each phase. Okay, phase 1, phase 2, phase 3, phase 4. Each of them need to be checked one by one. Right? System out, print after pass, trace statement. Okay, we trace the statement, trace the statement. This is a helper method to swap values into array. Okay, this is the code to swap. First, swap with second, and then the second is equal to temporary. Put temporary in second. Store it in the first temporary. Okay, so temporary swap, the value is gonna be put in another variable called temporary. Okay, after they do the swap, then they're gonna list out again the value. Okay, because when you put it inside here, the value inside here, okay, if you don't put it somewhere, it will not put the value will not go anywhere, so the swap cannot happen. So when you put a value inside the temporary file, example, so when you swap the place for the previous number, then the number inside the temporary file will get out or will be taken out, and then it will replace again the place that it replaced before, yang the one that changed to the second place. Okay, so we need to put a temporary file. Okay, so this one static void display. Okay, just they want to set the array again in the list. All right, so the number of array, this is it. This is the one that they need to store. Okay, what does it use? It uses bubble sort. Okay, bubble sort, number of array length. So it prints out after bubble sort, array will change the number of like this. Okay, so it's better for you to analyze the code. Okay, because we declare it the number of to be bubble sort is last code. Okay, this is the bubble sort. So this is bubble sort, everybody. Right. Sort array.java method header and use the compare to method for comparing adjacent array element. Okay, so we use bubble sort and then we use the compare method, compare to. Okay, so this is sort array. So in sorting, okay, in sorting, everyone, we see that we can also use, okay, the sort array. This is sort array. We want to look for the bubble sort. Okay, this is the bubble sort. We have a few more codes. Okay, right. So this is the bubble sort. Okay, it compares. Okay, T extend the value to this extension. Okay, extends, and then it compares to this value, and we never know this t, the parameter was the parameter for t. Is it below here? Is it below here? Okay, t is the value. Okay, that is the variable that they need to sort. The integer is put below here. Okay, so yes, before quick sort, bubble sort, quick sort. Okay, why does it use quick sort? Okay, we haven't learned quick sort yet. We just learned bubble sort. Okay, so here this is a value 90, 40, 20. Okay, so this one, the first bubble sort, Dan and Zoe, Jet and Bin. The last one would be, okay, this is the number for quick sort. Okay, so we sort it by name and sort it by numbers. Okay, integer. Okay, sorry, we sort it by string and we sort it by integer. Okay, so this bubble sort is used to compare the code like this. Okay, so this is a way that bubble sort is implemented. Okay, yes, right. So now we learn how you organize the sort. Okay, you organize the sort. How do you organize the sort of an array? Okay, so just see just now we have a lot of sample of code where you see those sorting method is implemented. So now we look at how you want to include. Okay, all right. So let's say we have a class here. Create a class. Okay, create a class of static sort method that performs the sorting algorithm. Okay, the method defined is type T for the object in the array. Okay, T is used as the object, but the value you need to declare it at the end. It's already declared at the end of the code. Okay, to sort an array of an object, the object in that array must be comparable. Okay, so what does it mean by comparable? So for you to sort the object, object in that array must be comparable, meaning to say we ensure that the requirement is met. T compare by T. Before you return type in the header and the sort method, we can use T as a data type of the parameter and local variable within the method. Okay, we use T as the object. We just need to find the local variable. Okay. So for this example, as you can see, we can use string as the local variable or integer. Okay, or integer. But you must compare it. Okay, let's say compare. Okay, it's compare it to what? To what value? Okay, this is the method. Partition index. Okay, I can see that it compares integers. Okay, this is for quick sort. Okay, this one not yet. This one, okay, this one. Okay, integers. Okay, so it compares with integers value. Comparable. Okay, so this one, I think we should use this array. Okay, print array. So it's gonna use this integer for the number of array. Okay. Yes. All right. So this one's gonna be used for bubble sort. Okay. This one haven't yet. This one is used for quick sort. Okay. All right. Yes. Object that array. Okay. When you see a string, you can actually compare it. Okay. Integer. Sorry. When you see integer, you can compare between integers. Right. So this is another example for selection sort. Okay, bubble sort already done. Now we look at selection sort. Okay, this is the analogy of rearranging a book. So this idea came when rearranging the book on a shelf by height. Okay, so we have height. right? The shortest book should be on the left. Okay, should be on the left. So we can see which book is shorter. We approach them like this. Look at the book, select the shortest book, swap it with the first book, look at the remaining book, select the shortest, swap it again with the second book, and repeat. Okay. Do you all get the idea what the example he is trying to explain to you all? This selection sort, meaning to say you have to do the swapping manually. Okay. By what method? Okay, for this book, maybe we want to observe the book's height. But in the programming way, I can tell you, you have to put in specific condition or a loop or a parameter, okay, to test the condition. Okay, you test them. Maybe you put the height there to maybe 5 or 10 inch. Then you declare variable of different size of integers or different size of string. Then you can compare them using selection sort. Okay, right. So okay, so this is the example that we use a text. We use a text, but let me draw this for you all. Okay, let me draw. Let's draw for you all. Okay, make n1 passes through a sequence of n elements. Okay, we have n elements. Maybe we have n1, n2, n3, and n4. Okay, n1, n minus 1, n minus 1, it can be anything. If it's 0, 0 minus 1, so minus 1, 1 minus 1, 0, 2 minus 1, 1. Okay, all right. So the first pass would be the smallest element on the sub-array. Okay, n1, n2, n3. Okay, we get maybe 10, 2, or 3, or 10. Make it 15. All right. So the smallest element from the sub-array, 0, and 0 till n minus 1, from left to right, this example. Okay, 10 to 3, 15. Then the swap the smallest element with the element at location 0. Okay, so Kelvin, as you can see from this search list, 10 to 3, 15. Which is the smallest element that you can see?
2.
Okay, 2. So you select 2. So that is how you do it. Okay, you select it. You select 2 and then you move it to the first number. So N2 is gonna move to the forward array. Okay, second pass. Find the element from the sub array. Okay, now 2 has moved here. So 10, this one, no more. This one, no more. All right. So again, we ask Kelvin, from this 2, 10, 3, 15, which one is the smallest element?
2, 10, 3, 15. Is it 2?
2, 10, 3, 15. 2, 10, 2, 10. The new array is 2, 10, 3, 15. Which is the smallest array that you see from the sub array? 3, right?
3.
Okay, you see 3. So you select 3. So 3, where do we move it? To the first selection or between 2 and 10 of the sub array?
So between 2 and 10.
All right, correct. So 3, we move it here between 2 and 10. So that's what it meant by location 1. Because our array starts from 0, 0, 1, 2, 3, 4, 5. So the first array just now, the 0 location would be 10, but we see 2 is the smallest. So 2 is going to take over the location 0. Okay? So 2 is going to take over the location 0. So
isn't since 2 and 10 swap places, then doesn't that mean the 10 will be at location 1?
yeah, correct.
So 3 swap with location with 3 swap with 10.
So 3 is gonna take over 10. So 3 is gonna be moved here. So 10 is gonna move here. So the new rule is 0, 1, 2, and 3. So 10 is gonna be at location 2. Location 1 would be 3. So you swap it using your selection sort. Okay, understand?
Yeah.
Okay, because you this one you already swap them, so 10 is no more and 3 is no more. Okay, so we have 2, 3, 10, 15. So 0, 1, 2, and 3. So the new location for location 1 is 3 lah. 10, it will move to location number 2. How you select and then you sort them. Correct? Okay. So do the same until the second last array location has been processed. Okay, so you select between 10 and 15, which is the smallest? For sure, it's 10. So 10 stays where it is. So this is the correct selection sort for the sub-array. 2, 3, 10, 15. Okay? Looking at the condition, if you want to find the smallest element, then you do it like this way. But if the condition is stating that you want to find the highest element, okay, the biggest number or the largest number of element, so we move it back sideways. We just reverse the process, making like 15 would be to the location 0, 15, 10, and then 3, 2, right? Okay, so now you know the idea. Okay, you know the idea. So let us see the advantage and disadvantage of it. Okay, you see the advantage and okay. Selection sort, the advantage here is that it does not depend on the initial arrangement of the data. Okay, what does it mean by it does not depend on initial arrangement? Okay, you never know the arrangement is actually true or not for the array arrangement, because when you do a selection sort, it depends on the condition. You have to follow the condition. So the initial arrangement is not actually true, or it has not been settled or executed or implemented, or it is not considered the array or the selection that you want. It can be anything, because you have to insert selection sort first, depending on the rule that the code want. Okay, a bit more efficient than bubble sort. Okay, you can see bubble sort compare one by one. Okay, you compare it one by one until the large number would be at the back. But for selection method, it's better than bubble method. Okay, bubble sort. Selection, you choose and then you swap. You choose and you swap. Okay, and it can make only one swap during each pass. Okay, when you see a bubble sort, you have one phase. It has how many swap? If the first largest number is in the front, then you need to have to pass 5 or 6 numbers. So we have a lot of pass and we have a lot of swap. But only one swap is involved when you use selection sort. You select something, you move it to the front. Okay, then you select again, you move to the front. Okay, you don't need to do multiple phase and then multiple swap. But the disadvantage of it is it is only appropriate for small size data. Okay, you all know what it means, small size data. When you have small size data, your data is very specific. It's not that too condensed. So you can do sort method, okay? Selection sort. But for big size data, we have another algorithm for those. And selection sort would be at a disadvantage if you use small size. Okay, if you use large size, small size, okay, no problem. You can use selection sort. Right? Yes. So this is selection sort. Okay, it's quite easy. This is the original number. So you have this array list 0 to 5. So yes, even though we have a lot of pass here, but for each pass, Okay, each pass we only swap one time only. Okay, so the original would be at the pass 1. Okay, pass 1 you swap 1 and you swap 2 times. Smallest element in index 0. Okay, you swap directly. So okay, actually you are doing one swap only. 8 is moved to the first, 23 is moved to the location where you swap the number. Okay, and then you see, you compare. Okay, this is sorted. Okay, and then you compare again. This is the first pass. You compare 23 and 78, which is the smallest. Okay, 23 is still the smallest among the unsorted list. So 78 is moved to the back to array 3, location 3. And we're gonna we select the 23 to move to the front, to the location 1. Okay, be wary of your location. Okay, when you explain in the exam, you explain it using the location. All right.
Do we need to draw also?
Yes,
Oh,
you
yeah,
need to draw. Okay, just draw it like this simple diagram. Okay, you draw 0 first, this array. You draw this first, this array, and according to the question, this number, you draw it like this. And then you use your ruler to directly draw out the line so that you don't confuse yourself. Okay, draw it like this. Okay, and then your explanation, your description, maybe you can use this diagram. You can explain at the back here. Okay. Okay, you explain swap smallest element with index 0. So the smallest one, you swap it with element 0, index 0. So 8 is the smallest one, correct? So 8 you swap to the index 0. So index 3 or array location 3 is swapped by the first number in the index 0. So you just swap them like this. Okay, don't forget to draw the arrow. Okay, don't forget to draw the arrow when you do the when you explain your selection sort method algorithm. Okay, you draw and then you explain. Again, don't forget to write down the sort. Okay, don't forget to write down the sorted indicator there. You must indicate that that is sorted. So each pass, you have to state the sorted, okay, the sorted numbers. The one that you already sorted, you don't need to swap it again because that is the selection that you select at the first phase. So that you remember each phase, how many phase you need to actually get the number to be sorted in an increment, okay, in a decreased number. Okay, from left hand side to the smallest number to the right hand side with the largest number. Okay, so it keeps on repeating like this up until you have the last phase. The last pass would be pass 5. And you see, okay, it's the same as bubble sort, but bubble sort, you can see the number there from the front, it moves to the back. But each pass has a lot of swap. Okay, that's why bubble sort, it only needs 4 pass, but each pass has a lot of swap. But for this selection sort, even though it's too much of a pass, up until 5 pass, but each pass only require 1 swap. Okay, each pass requires only 1 swap, and then you are able to finish the selection sort. Okay, so this one, remember, your sorted list, the number you sort, it starts from the front. Okay, but for bubble swap, it starts at the back. Okay, this is for bubble swap and this is for selection swap. Okay, don't get confused. Okay, so this is how you sort them out using selection. Okay, you choose them and then you put them and then you list out, it is sorted. Okay, that's why sir remind you all, this is important. This is important. The swap, the number that you state, the number that is already been sorted, you set them that is sorted. Okay, so that you don't forget where you want to select again. The number that has been sorted, you don't need to swap them. Okay, you don't need to swap them again. Like this one already sorted, you put it inside, and then 32 is not again, it will not be sorted again because you already sort them. Okay, those who have not yet marked or labeled with sorted, that is the one you need to put the red arrow, and then you need to move them, okay, from each pass, right? But if you all able to draw it, okay, you are able to visualize it. Okay, that's why everything, when you see this question, draw them first. Okay, maybe this question is situated at the back of the question, okay, at the back of the test, or maybe the exam. Okay, so you have time to draw them and you have to state your answers. Okay, yes, selection sort done. Now we look at iterative algorithm. Okay, iterative, we play with the increment and decrement. Okay, we play around with plus, play around with minus. We look at the statement first. Okay, index equal to 0. Okay, this is a selection sort, but we use them in an iterative algorithm. Okay, meaning to say, we put the code, the condition is for the loop there, they check this condition, index is equal to 0, where index is less than the number minus 1, and then they increment the index. Okay, index start with 0, and then we look at the condition and we start to increment increment it. Okay, so index of smallest number, what does it mean by smallest number? So the index with the smallest number, the index is equal to the index of the smallest value among the array or among the index. Okay, so that's why the smallest index would move to the left of the array. Okay, because of this rule, this condition. Okay, its index is always lesser than the number that is in front of the index. So swap the values of index and a of the smallest. Okay, so you need to swap them. So this is the condition to swap. Okay, swap the value in whichever the index has with the index of smallest. A is the smallest, so smallest number would always be at the front of the array. Okay, so A and N. Okay, A and the variable. Okay, let's check this one. Right. Okay, but in a recursive algorithm, just now we look at iterative. Iterative, you can easily understand it by the increment and decrement. But for recursive algorithm, okay, recursive algorithm for selection sort, recursive that takes 3 parameter, A, first and last. A is the array, the first index in the sub-array, and the last index in the sub-array. Okay? So this is how this recursive do. Okay, they check the statement first. Okay, they check the rule. A, it must be from A, the array. They check the first and then they check the last. The condition here is first is less than the last. What does it mean? First is less than the last. So first is always in front, and the last would always be first would always be lower than the last would always be greater than the first. So we know that the last number should be the largest number. So index of smallest here, the index of the smallest value of A and first and A and last. Okay, the check condition, check, and then we swap the value of A and with the index of the smallest. Okay, just now we see the example. We see 10, 10 to 3, 15. So 2 is the index of smallest. So 2 is gonna be replacing the first value, and the first value will replace the index of the smallest, and the one that changes now. Okay. Yes, selection sort A, first plus A, and then last. Okay, first plus A. Then first things we choose is the first. But then we see the first is included a +1 there. What does it mean? After you do the swap, okay, after you do the swap, the number of the first array will increment, okay, will be increased. Because before this, it's 0. The first array would be 0. But we see another smaller index replacing that first place. So the first place gonna be +1. Okay, or you put a mathematical equation there, you just plus it around. Okay, you just put it +1. Okay, if you don't put the +1, okay, if you don't sum it up by one value, it will not move from its first place. It will not move from the first index or the 0 index. Okay, the 0 index, it will not move its place from there. So you will get an error. Okay, you will get a warning sign. If you didn't put the first to be +1, they won't move. Right. Okay, so efficiency. How efficient is it? How efficient is the selection sort? Okay, text 0 time. Okay, text 0 open bracket and in the power of 2 close bracket time in these cases. Okay, what does it mean? Iterative method for loop execute at n at -1 times. Okay, so for each of the n-1 calls, inner loop executed at n-2 times. Okay, what does it mean? What does it mean? For you to have an effective selection sort, okay, whenever you have like an array list, okay, with different number, 10 to 3 or 15 like that, okay. So for each of the calls, the inner loop execute n-2. So n-1, n-2, n ++1, n-2. So recursive is like, okay, don't confuse yourself with the loop. Okay, because the loop will always use, when they use selection method, all you need to think of is smallest number is put at the branch. So when this number, it becomes a new array index, this is the formula for it. Okay, this is the formula of how they move the biggest number, the largest number to the end, and the smallest number, you select them to be at the front. Okay. I don't know why they want to this operation. You can learn them. You can take time to understand them. Okay, they have these two cases. That's why for iterative we use plus plus. That's why for recursive we only got like this condition. Okay, they compare like this. Okay, same operation but different method. Recursive is another one, and the one is recursive selection and iterative method. Okay, but just try to understand the one that we used the method just now. Okay. Okay, insertion sort. We have another insertion sort here, which we will continue. Okay, we will continue on the next lecture. Okay, I got scared you all got confused and your brain cannot take too much load. Okay, we stop at insertion sort. Okay, just now we already learned how many sort. We learn bubble sort, we learn selection sort, and for insertion sort, we will learn it on the next lecture. Okay, right? Okay, everybody, do you have any question regarding the two sort method just now?
No.
Okay, quite straightforward and easy. Okay, all right. So if there's no more question, okay, we end the lecture now. And I will see you all during practical class. Okay, during practical on 2 o'clock. Okay, just use the link that I share with you all, the latest link. That will be the link for week 1 until week 14. Only 2 links that will be, those are the links that we will use until week 14, right?
Oh, okay.
So we will not be generating a new link each time we have our class. We will be using the same link throughout the entire week until week 14, right? Okay, so if there's no more question, I will see you all during practical at 2 o'clock, right? Okay, thank you
Okay.
everyone for your
Thank you, sir.
attention and time for this lecture, and I will see you all this afternoon. Thank you and have a nice lunch this afternoon. Thank you.
Okay. Thank you, sir.